Suppose that we have the following problem. Let's consider a particle with a velocity function of 4t minus 2, say meters per second, and we are interested in finding the time that it will take this particle to displace 4 meters. So find the time it will take this particle to be displaced 4 meters. In other words, what we're trying to look in here is for the net change of the particle. If you remember, we had that in general, the net change theorem is telling us that the integral of the net change is just given to us by the difference of the antiderivatives. So in other words, if we apply the equations that we have over here, what we have is that we're looking at the integral of 4t minus 2 dt to be equal to 4. Notice that we don't have a specific starting and ending point. So what we're going to do is we can assume that our starting point is 0 and our ending point is t. Notice that this is basically a notation that we're using. In other words, we're interested in finding the time interval for which that particle is going to be displaced by 4 meters. So it doesn't really matter where we start and where we end as long as the time difference is going to be the same. So in that case, what we're looking for is really to solve this equation, or in other words, find the value of t, pretty much like what we did in class. So let me work it out. We have that the integral between 0 and t of 4t minus 2 dt is going to be given by, again, we can just do the reverse power rule in here, 4t squared divided by 2 minus 2t. We want to evaluate this between 0 and capital T. So this will become 4t squared divided by 2 minus 2t minus everything at 0. So 4 times 0 squared divided by 2 minus 2 times 0. And whenever we simplify this out, we will get 2 capital T squared minus 2t. So on the left hand side, we have that that's the result of the definite integral. That means the net change. And this is the condition that we are imposing. We want this net change to be actually equal to 4. We're looking for this displacement to be 4. So we can just write it down that way. And that means that now what we're looking for is to solve for t. We want to find capital T. In other words, what we need to do is we need to just solve this quadratic equation. So we have negative 2t squared minus 2t minus 4 equals 0. So we can approach this in several ways, but I'm just going to use the straightforward way that would be to apply the quadratic formula. So we can also factor it, we can graph it, we can plug it into a calculator, but again, just let me use the quadratic formula. So this is telling me that the values for t, we potentially have 2 values for t, are going to be given by, if you remember the quadratic formula, that is negative b. So in this case will be negative minus 2 plus or minus the square root of b squared minus 4 times a c divided by 2 times a. So that is me just reading off the quadratic formula. And now I can just simplify this expression. That will give me 2 plus or minus the square root of 4 minus, well, this will become a plus because I have this minus and this minus. So that will give me a plus in the end. And I would have 4 times 2 times 4. That would be 8 times 4. That would be 32 divided by 4, the whole thing. So this gives me 2 plus or minus the square root of 36 divided by 4. So I can do this one. This will be 2 plus or minus 6 divided by 4. And this gives me two solutions. This gives me 2 plus 6 divided by 4 and 2 minus 6 divided by 4. So the first one, that should be 8 divided by 4, which is 2. And the bottom one, that should be negative 4 divided by 4, which is negative 1. So we have two values. We have t equals negative 1 and t equals 2. But again, if you remember, the physical context of this problem was that a particle was traveling with a given velocity, and we wanted to find a time interval. In other words, capital T is time, and pretty much like what we mentioned in class, that means that we should only look for the positive value. The negative would not be relevant for us. In other words, what we have in here is that the time interval would be, in this case, 2 seconds.